Good afternoon, class. Today we're going to talk about the Pythagoras. So before I start with Pythagoras, I thought we're going to start with the definition. We're going to break the definition down and see if we can understand it from there. If there's time, we'll do an example then and just check how it works. So we're going to work from the definition to the formula to exercises to previous knowledge to an example if we have time for it still. So what we know about triangles equal 180 degrees. We all know that. So from the Pythagoras theorem itself, we need to have a 90-degree angle. So from previous knowledge, if I just draw a triangle quickly, we know that that sign, what does the sign mean?
It's a 90-degree angle.
That means a 90-degree angle, that's correct. So that will be 90 degrees, and the opposite of that would be our hypotenuse. Let's just go back to the definition quickly. The square of the hypotenuse, which is a new word for us, new word, and we've just worked out what the hypotenuse is, opposite of the 90 degrees. So what I normally do to work out or to find the hypotenuse is just to draw a little arrow from the 90-degree angle, opposite basically in the straight diagonal direction. Opposite of that will give us our hypotenuse, which is over there. The square of the hypotenuse is equal to the sum of the square of the other two sides. So if that's the hypotenuse, this will be an other side, and this will be an other side. Other side. Okay. So let's just go through a few examples quickly if we can find out what the hypotenuse, or to check if you guys do understand the hypotenuse. So I've drawn 6 triangles here. Let's just see here. We've got a 90-degree angle. What do you guys think will be the hypotenuse?
It would be C.
C, that's beautiful. So that would be the hypotenuse over there. And I draw my little arrow to show that's opposite. Number 2, what would be the hypotenuse?
Would be A.
A. Okay, that's got a 90-degree angle over there, that's correct. And opposite of the 90-degree angle, my arrow shows A, that's correct. Number 3, what would be my hypotenuse?
Be C.
C. Okay, it's got a 90-degree angle, that's correct. And opposite that, my little arrow shows that that is it over there. Number 4, what would be my hypotenuse?
It would be C again.
C, okay. There's my 90-degree angle. Opposite that, my little arrow shows C. That's correct. Number 5.
Be A.
A, beautiful. I've got my 90-degree angle, and my arrow shows the opposite, which is A. And number 6.
We don't have a 90-degree angle, therefore we cannot use Pythagoras.
Okay, we've got a 70-degree angle, we've got an 80-degree angle, and we've got a 30-degree angle. So we can't use it. You are correct. We don't have a 90-degree angle, therefore a Pythagoras cannot be used in that specific instance. So let's just go back to the definition. The square of the hypotenuse, we've just worked through what the hypotenuse is equal to the sum of the other two sides. So if that is the hypotenuse, those will be the other two sides, obviously. So we've got, let's just use triangle number 1 over here. Oh, my black pen is going. So we've got the square of the hypotenuse, which is C squared. C is the hypotenuse over there, it's equal to H, is equal to the sum of the other two sides squared. So we've got an A over there, which is squared, plus B, which is the other side squared. And that is basically what the Pythagoras theorem shows. This square root actually shows that it's the areas. So if I just draw a triangle, this is how he actually worked it out. Triangle, triangle. So Pythagoras actually said that the area, we obviously know what an area is. Eh? The area is actually the sum, or the distance inside of the actual block over there. That is what the area is. So Pythagoras said that And that will give us what that is. And if we, that will give us, let's work out the measurement, say meters, 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 squared, squared, squared. That is what the unit of area is meters squared. And if we've got that meter squared and that meter squared, we can actually work out what that horizontal distance is by working it backwards to its original meters. Let's use an example to find out. Draw another triangle quickly. Triangle A, B, C, exactly the same as what our formula is. So I'm going to give a unit to it. So our unit is, let's say 4 millimeters. Let's say our unit for this is 3 millimeters. Right, let's work it out. So we know that our formula C squared is equal to A squared plus B squared. We've got the units for A. Please don't forget the brackets. A is 4 squared plus 3 squared is equal to C squared. Now we already know that because it's showing squared and squared, our units is going to be millimeters squared, which is equal to areas. And because it's equal to areas, we have to work it back to find the actual meterage. So what we do is we calculate 4 squared is 16 plus 3 squared is 9. Please don't forget to bring down that C squared. We know that C squared is equal to 25. And what is the opposite of the square root? The opposite square, it will be the square root. So we'll have to square root this 25, and if we do that, we work into 5 millimeters. And that was millimeters squared still, so that was still area. And if we just move it down 1, we square root of that area to get rid of the square, will equal distance. And that is basically the Pythagoras theorem. So we work through the hypotenuse to work through the hypotenuse and the definition to get to the formula, and then we did one example. From areas, we're working back to distance. Thank you very much.